All right, so this is our example for going through a confidence interval problem. So it says students investigating the packaging of potato chips purchased 6 bags of Lay's potato chips marked with a net weight of 28.3 grams. They carefully weigh the contents of each bag, recording the following weights in grams, and those are our 6 different sample weights of chips, bags of chips. So we're going to create a 95% confidence interval to estimate the mean net weight of all of Lay's potato chip bags. So that is our goal. This is what we call it is a one sample t interval. Again, we're using t because I do not know the population standard deviation. I have the data, so I can figure out the sample standard deviation, but I do not know the population, and I have a very small sample size, so that is why we're using a t interval. One sample means I just am dealing with one sample of data. That's all I'm looking at. So we're going to go through our steps, starting with define the parameter. So we're dealing with numerical data. We're defining or dealing with a mean. So my parameter would be mu, is the symbol we use for the mean of an entire population. This is what I'm estimating. So mu equals the true mean weight of all Lay's potato chip bags. Our second step is to check conditions. So condition number 1, we were not told anywhere. It says they just chose 6 bags of potato chips. So it was not a random sample. So I would say something like assume these 6 bags represent all Lay's potato chip bags. My second condition is the 10%, which again, it's okay for you to skip it. I'm going to go ahead and write it. We're assuming that these 6 bags is less than 10% of all Lay's potato chip bags. Very easy to assume that. And then our third condition is our check for normality. And this is where we have to kind of look through our options. So the first option is where we told the population was normal. I don't want to erase stuff that's there, so we're just going to read through it. We were never told in this problem that the population of all the weights of all Lay's potato chip bags is roughly normal. So we were not told that. Second way would be sample size. I have 1, 2, 3, 4, 5, 6 in my sample. 6 is not bigger than 30, so I cannot assume my sampling distribution looks roughly normal based on sample size alone. So my last option is to actually draw some type of graph of this data and then to look at that graph and see if I can assume normality from that. So I'm going to do that down here. When I get to calculator stuff in another video, I will kind of talk through how I could put a graph of this in my calculator, but I would still need to then transfer it to paper in some way and label things really well. I just find it easier to do a quick dot plot like I'm going to do here. So I'm going to do a dot plot. My numbers start a little bit above 28 and go through like 29 and a half-ish. So I'm going to do that. There's half, and then we'll say that's 29 and a half, right? So I'm just going to start putting dots. So 29.3 would be about here-ish. I'm going to put a dot above that line for every number here. So 28.2. All right, so that's it. That is my graph. Now again, it's very small, right? We only have 6 data points. It's not going to look perfectly normal, like it's not going to have this kind of shape because I just don't have a lot of data to go on. So again, what I'm looking for with this graph is, can I assume from this graph that my population was normal? Or more accurately, do I have any reason from this graph to think that the population was not normal? So because I don't see any major outliers, these points are all generally pretty close to each other. There's no kind of crazy, really far away points. If I had like this lower point were like at 20 or 21 or something like that, that might lead me to believe that the population is skewed to the left. If this high point was up at like 35, 36, 37, that might lead me to believe that this population was skewed to the right. But because these are fairly close to each other, I don't see any major outliers on one side or the other, that's going to be enough for me to assume that the population of all weights of all bags of chips is roughly normal. How I would say that is, I'm going to say no major outliers in sample data. And then my favorite phrase of all time, normality is plausible. Such a fun phrase, but it gets used a lot in this case. All we're saying with that is that it's reasonable to think, based on our sample data, the population looks roughly normal. So that's our conditions. So the next step would be to go into calculations. And to do that, we also need to know the mean and standard deviation of this set of data. So in the calculator video, I remind you of how we can use our calculator to get that information. For the sake of right now, I'm just going to go ahead and put it up here for your benefit. So the mean X bar is 28.78 with a bunch of 3's after it. And then our standard deviation S is 0.402. So you do need those in order to use the formula. Again, I will have another video just with calculator stuff where I go through that part. Also, as a side note for conditions, I do need this graph as part of it. It's always helpful if you label it. So like weight and grams, always label your graphs. But that should be part of your kind of conditions, just FYI. So now we're ready to go ahead and do our calculations. So again, just as a reminder, our formula is we're going to have our statistic, which is X bar, plus or minus critical value T star, times standard error, which is S over square root of N. I'm going to plug in all of my information. So X bar was 28.78 plus minus critical value, I'll grab that in a second. S was 0.402 over square root of N, where N was sample size, so 6. So now I'm going to go back to my T table and grab that degree or that critical value. So I wanted a, what did I want? 95% confidence interval. And I had a sample size of 6, so my degrees of freedom would be 5. So 5, and then 95%, I can check on the bottom, 95% is this row right here. But I can also remember the whole tail probability thing should be 5. So degrees of freedom 5, 95% confident is a T star of 2.571. So 2.571 is what we're going to put right here for our T star. And then from there it's math, so we would use our calculator to figure out our interval. I'm going to go ahead and do that. So once I've typed those in my calculator, being very careful about order of operations and all of that stuff, the interval I get is 28.358 to 29.202, let's say. And this is grams. We do have a unit now because this is an actual number or mean, not just a proportion. So my last step is to interpret this. So I do that in the same way that I did before. We're just talking about a mean now instead of a proportion, and I have units that I need to include. But I'm basically saying the same general things that I said with a confidence interval. We are blank % confident that the true blah, 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 blah is between this and this. So I'm going to go ahead and do that and write that out for this problem real quickly so you can see what that looks like. So there's our confidence interval interpretation. We're 95% confident that the true mean weight of Lay's potato chip bags is between 28.358 grams and 29.202 grams. So if you remember kind of the claim or what the chips were marked as was 28.3. So if we were asked the question, do we have evidence to say that the true mean is not 28.3, that it's different from what they said? Based on this interval, yeah, 28.3 is not in this interval, it's slightly below. So we actually have evidence based on this data that the true mean weight of potato chip bags is a little bit higher than what they say, because that entire interval is above 28.3. So according to our data, we are a little bit above, right? If 28.3 were inside that interval somewhere, we would have to say, no, we don't have evidence that it's higher or that it's different, because 28.3 is in the interval, which means it could be the true mean based on our interval. Right? If we were asked to interpret the confidence level, what does it mean to be 95% confident in this problem? Right? Well, that's where we'd say if I took a whole bunch of samples of 6 bags of chips and did a confidence interval for each one of those, about 95% of the intervals would include the true mean weight of Lay's potato chip bags. So if I repeated this process many times using this method, about 95% of the intervals would include the true mean weight of all potato chip bags. So that's a couple of things you can do or interpret based on this interval. There's going to be one more video that's looking at calculator stuff, so how to get the mean and standard deviation from our set of data that we were given, how to do this whole interval process a little bit quicker, stat test menu. I'm also going to look at, just real quick, how I would graph the data as a histogram on my calculator if I wanted to do that for that third condition instead of graphing it by hand as a dot plot. Just remember, you would still have to draw that graph on your paper anyway. But those are a couple things I'll be looking at in the calculator video, so check that out. And otherwise, we are done.